solve the differential equation y prime is equal to 4x times 2 plus y. Y prime is equal to dy dx, Leibniz notation. We replace y prime by dy dx, and then I'm going to write the right part like this: 2 plus y times 4x. Why? Because I want to divide later on by 2 plus y. When we cross multiply, dy dx is equal to 2 plus y times 4x dx. Then we're going to divide by 2 plus y. Dy dx over 2 plus y is equal to 4x dx. The variables are separated. Take the integral of both sides. U prime over u, the integral of u prime over u is ln absolute value of u. The integral of dy over 2 plus y is ln the absolute value of 2 plus y. The integral of 4x dx is 4 times x squared over 2 plus c. Ln absolute value of 2 plus y is equal to 2x squared plus c. We're going to take the exponential of both sides, and when we do, ln absolute value of 2 plus y will be 2 plus y. And using the laws of exponent, e between parentheses 2x squared plus c is e 2x squared times e to the c. And e to the c is a constant. So 2 plus y will be equal to c, that constant, multiplied by e to the 2x squared. Subtracting 2 from both sides, y is equal to c e to the 2x squared minus 2. The general solution to the differential equation. We'll box it. If the rate of change of variable y is proportional to the value of y, if y is a function of time, we can write the proportion as dy dt is equal to ky, which means the rate of change of y is proportional to y. When we take the integral of both sides and solve it, y will be equal to cekt. The rate of change of p with respect to t is proportional to 10 minus t. The rate of change of p is dp. With respect to t is dt is proportional to 10 minus t equal k times 10 minus t. Cross multiply, dp is equal to a constant k times the expression 10 minus t dt. Now, when we take the integral of both sides, we get p is equal to k times the integral of 10 minus t times dt. We need a -1 to be able to integrate, so we multiply and divide by -1. Remember that we cannot break apart 10 minus t because we have to consider 10 minus t as a whole and not as a sum of two functions. We're gonna get k divided by -1 times 10 minus t squared over 2 plus c. We multiply 2 by -1, we get negative k over 2 times 10 minus t squared plus c. Here's a quick look at the solution. The rate of change of y is proportional to y. dy is equal to ky. Now, if we divide by y, we get dy over y is equal to k. Y is a function of time. So when we take the integral of both sides, we get ln y, ln absolute value of y, but y is positive, is equal to kt plus c. Now we'll take the exponential of both sides to solve for y. E ln y is equal to y. Ekt plus c is ekt times ec, and ec is c. So it's c ekt. Now, t is equal to 0 when y is equal to 2. Let's just substitute. 2 is equal to c e, and kt will be 0 times k, which is 0. E to the 0 is 1, therefore c, the constant, is 2. Now when t is equal to 2, y is equal to 4. We're going to solve it for k. 4 is equal to 2e k times the time, which is 2. Divide both sides by 2. We get e2k is equal to 2. Now we're going to take the ln of both sides to solve it for k. Ln e2k is equal to ln 2, which means that 2k is equal to ln 2, and k is equal to ln 2 over 2 when we divide both sides by 2. Ln 2 divided by 2, 0.347, approximately 347. Now the growth model will be y is equal to c, which is 2, e, k, which is approximately 0.347 times t. Now when t is equal to 3, we need to find the value of y. Let's just replace t by 3. Therefore, y will be equal to 2e to the 0.347 times 3. When using the calculator, only use one pair of parentheses for the exponent. 0.347 times 3, and then close your parentheses. The answer is approximately 5.66.